topic that we're going to go over for the Unit 1A assessment video. So let's look into it, okay? So we already looked over the number system, all right, rationals, irrationals, whole natural numbers, okay? That was the first thing we did. Then we did converting repeating decimals to fractions, okay? After that, we did approximating square roots. That's what we just got done doing, all right? Now we're going to look at using the laws of exponents. Before we look at using the laws of exponents, I forgot to give you guys the assignment for approximating square roots. So here it is. The first one you guys are going to do is the square root of 22 is in between what two numbers? All right. Second one's going to be the square root of 54 is in between what two numbers? Then square root of 87 is in between what two numbers? After that, plot each one on their own number line. Okay. Then write two really short sentences about their position relative to the number line. So square root of 22 is to the left of, to the right of. Square root of 54 is to the left of what number, to the right of what number. Square root of 87 is to the left of what number, to the right of what number. Okay? And then after that, here we have, it says, between what two integers is e squared? All right? So you guys should know about e. E is an irrational number. Okay, and here I give you some of the digits, all right, and you just need to approximate it, okay? Approximate what is going to be in between. Process of elimination works very well on this problem, okay? You may also want to refer to the pi cube video that I made in approximating square roots part 2, okay? It's at the very end. It's the last example that I covered, all right? So now let's get into the laws of exponents, okay? So remember the first law, okay, the law that we very first looked at was x to the a times x to the b is x to the a plus b, okay? So maybe we'll review this real quick. Remember x to the a. X is called the base. A is called the exponent, okay? So let's look over here. So we have x to the a times x to the b, where we have the same base in each one, x and x. If you multiply them, so x to the a times x to the b, you get x to the a plus b, okay? You just add their exponents if the bases are the same, all right? Similarly, for division, okay, x to the a divided by x to the b is x to the a minus b. Okay, you just subtract them, all right? Here we have this thing called power to a power, okay? So we have x to the a to the b, okay? When you have that, all you do is multiply them. So you get x to the a times b, all right? Number 4 is the fourth law says x to the negative a is just 1 over x to the positive a, okay? So if you have x to a negative number, you just do 1 over x to the positive of that number. That's how you get rid of the little negative, okay? And we have number 5. It says that x divided by y, all raised to the a, is the same thing as just raising each one of these to the a, okay? So it's like we're like distributing the little a and the exponent to each one. So you get x to the a over y to the a, all right? Same thing for multiplication, okay? X times y to the a, you just distribute the a to each one. So you get x to the a times y to the a, all right? 7 and 8 are very important, and you need to know them. X to the 0 is 1, okay? So that what this means is any number raised to the 0 is 1, okay? Anything to the 0 is 1, all right? We have something similar for 1. X to the first power, or x to the 1, is itself, okay? So x to the 1 is just x. Anything to the 1 is itself. So 5 to the 1 is 5. 6 to the 1 is 6. 10 to the 1 is 10. Let's look at a couple examples of using these laws, okay? So here we have 6 cubed times 6 squared. First things first, we look to see if we have the same base. In this case, we do. The base here is 6, okay? And we're multiplying, right? So we can go ahead and look at law number 1. What does law number 1 say to do? Law number 1 says if you're multiplying with the same base, all you have to do is add the exponents. So 6 cubed times 6 squared, you get 6 to the 3 plus 2, but 3 plus 2 is 5, so you just get 6 to the 5. Okay, it's that easy. All right. The second example says 5 to the 7 times 5 squared. So you check to see if you have the same base. In this case, the base is 5. So we're multiplying. We'll use law number 1. X to the a times x to the b is x to the a plus b. So we just have to add them. So 5 to the 7th times 5 squared is going to be 5 to the 7 plus 2, which is just 5 to the 9th power. Okay. Same thing over here. 5 to the 8 times 5 to the 10. Do we have the same base? Yes, the base here is 5. And we're multiplying. So all we have to do to solve this is just add their exponents. And we get 5 to the 8 plus 10 is equal to 5 to the 18. Okay, and that's all you have to do for these. Okay, they're very straightforward. And the test is similar. So if you can understand these, you know, these are test level questions. So if you can understand these, then you should be fine. All right, for the x to the a times x to the b. All right, let's look at some other examples, but this time let's use a different rule. Okay, so now we see that we have quotients here. Okay, so we're probably going to end up using the quotient rule right here, which is x to the a divided by x to the b is x to the a minus b. So this one says if you have the same base, all you have to do is, and you're dividing, okay, so if you have the same base and you're dividing, all you have to do is subtract their exponents. Okay, so here we're going to have, and you always go top to bottom. Okay, so for example, 7 to the 7 divided by 7 to the 4th power is going to be, well, the first number here is 7 minus 4. So you're going to get 7 to the 7 minus 4, which is going to be 7 to the 3rd power. Okay? Same thing for the next one. Okay? First things first, you check to see if you have the same base. The base here is 8. Yeah, we have the same base. We're dividing, so we know to subtract their exponents going from top to bottom, no matter what those numbers are. Okay? So the first one that pops up is 9. So we're going to get 8 to the 9 minus, the next number that comes up is 5. So we get 8 to the 9 minus 5, which is going to be 8 to the 4th power. Okay? And we can do the same thing for this example. So 9 to the 5th power divided by 9 cubed, you will get 9 to the 5 minus 3, which is going to be 9 squared, which is the same thing as 81. Right, which is 9 times 9 is 81, right? And don't forget, guys, just because you simplify it, right, just because you get 9 to the 5 divided by 9 to the 3 is 9 squared, doesn't mean 9 squared is going to be one of your answers. The answer might be in the form expanded. So instead of 9 squared, the answer form might be 9 times 9. Okay, so for example, instead of 7 cubed, the answer might be of the form 7 times 7 times 7. Okay, you guys want to practice those, okay? So 7 times 7 is 49. Times 7 is equal to, well, let's go to the side and do that. 49 times 7. 9 times 7 is 63. Carry the 6. 7 times 4 is 28. 28 plus 6 is 34. So you get 343. Okay, so this is what the answer might look like on the test. Okay, it might be that you found out that this is 7 cubed, but then you need to convert it to what it actually is as a whole number. Okay,